Good evening everybody, this is a video addressing Tropical Cyclone Alfred and its situation and what's going on with Tropical Cyclone Alfred. It's expected to hit southeast Queensland and is expected to also affect far northern New South Wales. This is all in Australia, along Australia's east coast. I should note that it is very rare for a tropical cyclone to get down to this latitude in this particular part of the basin of the South Pacific, and Brisbane usually doesn't get that many tropical cyclones, if any at all, for the most part on average. We'll be looking at what's going to be going on with regards to impacts and Tropical Cyclone Alfred's evolution as it approaches the Sunshine Coast, Brisbane, the Gold Coast, and going into New South Wales. Hope you guys enjoyed the video, and I hope you guys find this informative and get all the information that you need, and hope you guys that you also get a bit of knowledge on your hand as well as I go through the also some of the technical parts of the evolution of Alfred and how it's going to be approaching the region over the next few days. So I'm going to begin by looking at the Bureau forecast cone that we have here. They've currently got it as a tropical cyclone, as a Category 2 tropical cyclone on the Australian scale, and they are expecting it to maintain Category 2 status up until it gets to this coast, and it's expected to then weaken into a post-tropical cyclone or an ex-tropical cyclone as it heads inland, which is fairly straightforward, I think, but we'll go through the environment and why it's expected to do that in a bit. But what do we have on this cone at the moment? Well, we currently have a tropical cyclone warning issued, which means gales within 24 hours are expected to begin, and that goes down all the way to Yamba, extending from Double Island Point, going through Sunshine Coast, Brisbane, Gold Coast, and then going into New South Wales down to Yamba, as I've previously just mentioned. We really don't usually get tropical cyclone warnings down here, the Australians don't, and it's quite a rare sight to see. Quite a marvelous. It's not marvelous, I should say, but it's incredible. That probably is the better word to use. This doesn't usually happen. We really don't see tropical cyclones this far south, going down this far south, down to Australia. We've seen a few cases, but they're very isolated and they've happened quite a long time ago for the most part. In recent times, we've not seen something like this. So it's quite incredible to see. And then obviously, yeah, if you are in this area, make sure to obviously take all the required precautions, read the tropical cyclone advice, look at any of the information that authorities have put out, and also refer to all the warnings, including the marine and weather warnings that are on the Bureau's website. What's going on with the system itself? Well, it's currently a Category 2, as I previously mentioned. It's got a storm force wind field, currently extending through 3 quadrants, looking at southeast, southwest, and northwest, with gale force winds extending across all quadrants. And then, what does the technical bulletin for Alfred have? Well, let's take a look. 50 knots, so storm force obviously as we've looked at, and it's got quite a big field. Storm force wind field extend through 3 quadrants, 100 nautical miles, 180, going through southeast, southwest, and northwest respectively. It's quite a big wind field. It's quite a broad system, and it's expected to stay that way. Maybe time up a little bit before it gets up to the coast. But yeah, impacts will be quite widespread, hence the cyclone warning is quite a big stretch of land that has been put out for. And the radius of maximum winds is 65 nautical miles. Again, that is big in itself as well. Something worth noting down. But what something doesn't add up, or initially it doesn't, is that we've got a T1.5 for the Dvorak T number, and that is quite low for a tropical cyclone of this intensity. You'd usually expect maybe a 3.0, 3.5 deep in the tropics, or when the environment is a bit better. But the environment is actually a bit horrible. It's not really the best right now. It's actually a pretty poor environment, and there are some reasons why Alfred is actually sustaining at a pretty high intensity as it is. I'll go into that later. Now, what's the forecast look like? Well, currently we have 50 knots initialized, and I was saying it is expected to maintain Category 2 status, but it will strengthen slightly. It might strengthen a little bit more than shown here, but it will maintain its Category 2 intensity as shown by the forecast, and it could even go into Category 3 on the Australian scale. And again, I will look through the environmental details to show you guys why that might be possible. Let's look through the remarks. Let's take a look then. It's maintained its strength as a Category 2 system, confirmed by the ASCAT and the AMSR2 passes. We're not going to look deep into those. It's not too relevant. We know that its Category 2 system is quite a broad system. We've gotten the confirmation by the Bureau. They're definitely a reliable source. I mean, I don't know why they wouldn't be. They are literally the officials in the basin. So, yeah. And then obviously, yeah, easy. The circulation is exposed, so visible imagery is able to help identify the center. DT 1.5, shared power and convective bursts, obviously shared environment, we can probably infer from that. And PT is held at 1.5. Objective aids are actually quite low, because obviously when it comes to objective aids and objective guidance, you've got DMINT, DPrint, and advanced and AI, Dvorak techniques. Obviously you rely on convective structure to be able to identify the intensity, and they're trained on that. And obviously you have some abnormal cases like here where I'll go through and explain why there is a baroclinic component which is actually helping to intensify the system a lot more, and it's rather than just tropical features. Which, if it was tropical features, you'd have much better organisation. But baroclinic features will involve shear, and therefore we've got such an environment and also such a strong system maintaining. And then obviously, yeah, the Bureau goes on to what I've just said, and it's under a subtropical jet. Deep layer wind shear, 40 knots, northwesterly. I'll go into the shear in a second. I'll show a current sounding or a forecast sounding for this time, and go over the environment. And that's the SIMS 0Z environment analysis. It will persist, and then it might decrease slightly. Phase-based analysis from numerical weather predictions suggests the system currently exhibits subtropical characteristics, which I don't deny it does. We'll go on to that in a second. I've said that so many times. Shallow symmetric warm core. Yes, one thing I will say to kind of go against that is the fact that there is no, there is a baroclinic component, yes, but it is also generally what the influences are still tropical. I'll go on to why that is. Sea surface temperatures 26, 27, close to the coast. Dry air wrapping into the system. Strong baroclinic component, as mentioned here, and the Dvorak environmental assessment little scale. It's biased towards numerical guidance, Category 3 cyclones before landfall, but yeah, current forecast up to 60 knots. I think that's intermediate, that's the intermediate point, and that's probably around in between two forecast points mentioned in the technical bulletin. And then mid-level ridge is the strengthening feature that will be steering Alfred westwards towards the coast. And then where it will come, between Sunshine Coast, Gold Coast, around that region, southeast Queensland, as I've said. New South Wales will still be getting impacts of some sort. Again, I recommend looking at the Bureau warnings and watches and whatever they have in place, whatever information they have up on their website, to get the best level information to protect life and property, or to do whatever's necessary to, be safe. It's to make sure everything's as fine as possible as Alfred approaches. Now, this is latest animated infrared satellite imagery, and currently we see, we do see that it's a very broad system, very broad circulation, taking up a lot of the space on the floater image. Yeah, and a lot of that convection displays to the south there. And that is the influence of very strong northwesterly shear, northerly shear impinging onto the system. It's very clear, even with that new central burst that popped up around closer to the center there. We can see here that it is still shit, and we can also see the circulation very exposed there, dry air and shear wrapping in and impinging onto the system prevents new convection developing on that side. The system remains quite strong. It's not a very organised system. If we look on the we get out of here and we look at the BD color scale, we can see here that even if we try to apply curved band, you know, like let's do let me draw. Let me just draw a little bit. You should not be doing this with the Dvorak technique, by the way. But if you take a very weirdly drawn log 10 spiral image, and you know you did this a little bit. This is very basic, by the way. Don't even try this. You can see you'd get like you really wouldn't get much of the sectors really within that convection. You're looking at about maybe 3 at max, and that would mean you have a log 10 spiral of 0.3 degrees, and that is a 1.5. Very general. Don't try this. You shouldn't be doing this. You should be getting a real log 10 spiral image and then overlaying it on top of the image. On top of the BD image, and then actually get an accurate interpretation. That's a very rough interpretation though. What I wanted to present is that when applying the Dvorak technique and you look at what sectors are in, you'd see there are very little that embed that are really on top of this convection, and therefore you really wouldn't get a high value. Best scene to use though is a shear pattern, because obviously it's it's a shear tropical cyclone. And because the system centers somewhere like there, and you're looking at convection going up to there, to the edge of the overcast, that's around 1 degree difference. And that is quite a low Dvorak T, a data T number that you would get out of that. Mainly, you'd use PT under this kind of environment, a shear pattern, because obviously shear patterns fluctuate, and therefore PT might be a bit of a better estimate to give. You'd still get quite a bit of a low estimate. That's a bit of a lesson for the Dvorak technique there, in a shared environment. I didn't show any images, and a proper lesson wasn't really given, but that's some information on how to apply it to Alfred. Yeah, going back to that dry environment that I mentioned, and that dry air wrapping into this, it's very evident that driest air is really like trying to head south, and is trying to go around our circulation. That strong, deep layer northwesterly flow really helping advect that dry air into the centre and into the circulation, with that convection isolated and sheared to the south. One thing what I wanted to say, by the way, that I would say can be used to justify a tropical classification is that we've got a lot of our convection there in this place, and although very disorganised and quite far from the circulation centre, very strong upper level anticyclonic outflow venting into the jet further south, which shows that is still a tropical feature. In subtropical systems, you usually have an overhead upper level cutoff low or a trough that would be representative of cyclonic motion up in the upper atmosphere. Here you have anticyclonic motion, and although we don't have central convection that still has any significant upper level anticyclonic flow coming out, we don't see much of that yet. It might start to produce that soon, and we can probably see like the way that it's evolving as well, and shear being in place. We see some of that. We see the kind of anticyclonic expansion of that convection in a way. It's almost like Cirrus is about to be coming out of that region. And yeah, we do generally have quite a dry environment, because we do have a very subtropical pattern, I'd say, in terms of synoptics and what we have in terms of environment. We have a lot of dry air coming in, so that's going to be another factor that prevents convection developing. And if we go into here, sea surface temperatures are only at about 20, 24, 25, and that's, the Bureau has analysed at 26, but it's probably slightly lower than that. This is coral reef, NOAA Coral Reef Watch analysis, and even if we look at the OISST mean, it's still 24, 25. It's not particularly high in this region, and why I say there might be a bit of a baroclinic component where we do have some dry air coming in. There is a cold air mass above, like a relatively colder air mass above. It is under a subtropical jet, so there will be a colder air mass near this system, and that's probably helping with regards to lapse rates. There probably is some enhancement of convection due to that, but still, largely tropical. We have anticyclonic flow around in the area. And again, we can see that anticyclonic flow is around, but one thing I did want to also mention is we do have an upper level low nearby. It's not directly overhead the system, which is why I'm skeptical to classify it as a subtropical system, but there is an upper level low there, cyclonic motion evident at the 251 to 350 level. And that is a cyclonic rotation, very evident. That's not over the center, which is here, but it is near. And that's probably helping with, it's probably supporting with the enhancement of the strong deep layer northwesterly flow that's coming in. It's probably that there's like this gradient being enhanced there as that flow kind of conjoins with the subtropical jet there, and it's all impinging into Alfred, and that's getting in some pretty tough dry air. But nonetheless, anticyclonic flow is there, and it is supporting the system somewhat. And yeah, as I said, there is it almost like looks like Cirrus is going to be coming out of that new convection that's developing, and it's evident looking on this on this upper level wind analysis. We can see some of that wind already, vectors going northwesterly, going to the southeast. We already see that convection expanding. So yeah, upper level anticyclonic flow environment is still around here, though that upper level low does need to be watched. Now, with regards to current environment and looking at it on a sounding is also quite interesting. See, we've got the Sims analysis that the Bureau mentioned in its discussion, that shear was around 40 knots. The upper level the upper level shear here is quite intense for the most part. We're looking, yeah, 40 knots, 45 even, extending up to the 200 millibar level upper levels. Mainly because that's obviously the kind of synoptic upper level pattern that we have, with the upper level low to the west and the subtropical jet overhead, which bring very strong shear, but it's all in the upper levels. And that's not to say it's not affecting the system, because it definitely is. But yeah, it's just a note that that's where the peak shear is. These shear levels, deep layer shear values, obviously nothing to take at face value. Generally, we also got to note, because there is some shear that goes the other way, and that is our low level to mid level shear. That's not of greatest concern here, because the greatest shear is at 40 knots, extending in the mid levels, the upper levels. And that's probably where the Sims estimate for 0Z came from, and then obviously that shear even further amplified. We got our very high level high shear extending at 45, even beyond 45 knots there, 200 millibars at 40 knots, and then yeah, it's again, it's a bit more of a wonky autograph now that it kind of stays at a higher magnitude for longer, if you wanna call it that, really. And then yeah, we have that low level mid level flow, which is generally easterly now. And we can even see here along the Scuti is our wind barbs, very strong northwesterly flow in above the 500 point. But that flow weakens at around this 700, and then we start getting some nice subtropical polar flow, polar low level flow coming in from the southeast, because there's a ridge below Alfred to the south, which bring that flow. So there's a lot of, I guess, disagreement within wind vector between most concern is that very strong, powerful deep layer northwesterly flow coming in above the 500 layer, which is going to affect that dry air. And again, it's presented there. Very low relative humidity values to north side of the cyclone. Relative humidity values, deep layer 60%. And for the most part, if you look on the Scooty there, very dry environment above 700 millibars. Very, very large difference between the dew point temperature and the standard temperature difference. Very, 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 very large difference between the two, which does indicate quite a dry environment. And if we're looking at all this in relation to the storm motion vector, again, it's only 9 knots, so it's almost stalling as well if you look at the current animated satellite imagery. It's almost stalling. If it's moving quite slow, and you've got all that northwesterly flow impinging, this is not good of an environment. It's managing to hold on just barely. Now, in terms of steering, this is the latest GFS run. We're going to look at the ensembles first. Here we got a nice deep layer ridge to the south, as I've just mentioned, and that's going to help steer Alfred west towards the Queensland coast. With amplification of that ridge and it heading slightly northwards, just a little bit, will help get Alfred on a bit of a north, to head it a bit west-northwestwards of a direction. That's way too west. That's way too north. But it'll head a bit that way for a bit before continuing its due westward movement, as that ridge kind of stops extending so far northward. I've just drawn a bunch of lines. I'm sorry about that. But yeah, if you kind of get what I meant, it's kept it a bit going like this. This is the ensemble mean for the most part, and it's general good agreement that there will be a ridge there, and it's not going to make some random turn north or south or whatever. It's going to likely head into Queensland, and that's probably going to happen by hour 54 at the time of recording this. It's currently 9Z, so if we're assuming a 6Z initialization, which it isn't, but let's assume it is, 50, around 50 hours or so from now, that's just over 2 days, we're going to get a possible strike in Queensland. And then system's going to head inside inland, I should say, sorry, and that ridging kind of becomes a bit more north-south oriented, and then there's a chance for it to head southwestwards and into the mid-latitudes. But that's inland, that's when it weakens. Most concern is obviously the track of Alfred, it being taken into Queensland by that strong deep layer subtropical ridge to the south. And the European ensemble, again, generally good agreement with that. That ridging slightly will continue to push a bit upwards before settling down, and then, yeah, allow Alfred to take that westward direction into Queensland before that ridge orients north to south, and then it gets taken by troughing that begins to pass by in the mid-latitudes, and it gets sent away. What do we have with the ensemble members as a whole? Is there good certainty? Yeah, there's decent certainty for the most part. If we look there, Alfred is over here, this is 6Z, and then it moves that way for the most part. That member density is for the most part quite tight, and decent confidence, not that much spread in terms of where the members are going to go. And yeah, we generally expect landfall just north of the Queensland New South Wales border within the Brisbane area. That's generally where we expect landfall. Decent confidence there. If we look at the EPS, similar confidence. Our confidence starts to drastically drop just after hour 60-ish, where a lot of the members start heading inland, and then there's some that stay offshore a bit longer, but then again, they do move inland eventually. So timing is, at least on the GEFS, on the GFS ensemble, it's fairly tighter, a bit tighter than the EPS. EPS, looking at it, quite a big spread in timing really. there's a bit of a difference. I think if we look like at the bulk of the members, we're looking at 12Z to 12Z. We got 24-hour window really, for for a good chunk of the members moving in. Big difference. Obviously, I think as certainty grows with time, I think we are going to get a bit of an indication of where that landfall will happen and when specifically, most importantly. It's generally a fair assumption to make. We're probably expecting it at around, if we're looking at local time, we're probably looking at about Thursday overnight into Friday morning for landfall. That's generally based on the GFS and EPS ensembles that we have here. In terms of environment, we have we have that deep layer northwesterly flow in the subtropics. That subtropical jet going through. Well, it's not really deep layer, I should probably clarify. This is a very strong 200 to 500 millibar subtropical jet that's impinging onto the system, and as I said also earlier, this upper level low brings cyclonic motion and then going and converging into the subtropical jet to the north. That flow does get amplified, and we got darker colours there within this region, and that is amplified by that upper level low curve that is bringing in some flow converging with that subtropical jet. And what do we also have? We also have upper level anticyclonic outflow. I should probably begin by saying we've got some from the isolated convection, we've got some isolated anticyclonic outflow there to the south of the system center, and then we've also got an evolution that progresses here where that upper level low weakens quickly, becomes almost unrecognizable, and it eventually does, and then Alfred moves westwards under the subtropical jet, or to the south of it, and that shear does actually eventually lessen. We'll go into model soundings in a second and look at forecast soundings and take a look at how that shear pattern over the system evolves. But yeah, very clearly here we see it enters this subtropical area of low shear. We see the polar jet going down there, and then the subtropical jet going over that way. And it goes through, and then because obviously it has room now, it has breathing room, and there's no jet really interfering over the core, it now actually has breathing room to now extend its tropical nature, and its anticyclonic outflow now is allowed to spread outwards, which eventually does quite strongly as an already relatively strong system, and it's able to intensify slightly as a result. Then it moves inland. It still remains over a somewhat low-level shear environment in that small area, small pocket of low shear, but that subtropical jet does eventually close in on it, and yeah, as it moves over land, that also ends up resulting in it dying, dissipating, with its remnants probably contributing some heavy rainfall after the landfall. But there is going to be a very, very strong heavy rainfall risk as it obviously goes at landfall as well. As a broad system, and as a generally erratic system as well, there is going to be quite a few significant amounts of precipitation. I should probably word that a bit better. There's going to be quite a lot of precipitation over the next, over the course of a few days, a day or two, as it makes landfall, and as it moves slowly inland near Brisbane. That's going to bring some pretty heavy totals, pretty serious totals, I should say. What might be worth actually looking at is a pretty wise thing as well. Well, first of all, let's take a look at the ECMWF. I was thinking of taking a look at the hurricane models, the hurricane regional models, but we will look at the other global model, the other major global model that we have as well. It shouldn't be too different, especially with such a short, such a near-term evolution. That's usually going to be with fair confidence between the two models. And again, yeah, very similar evolution to the GFS, that upper level low, unrecognisable, breathing room now to actually expand its upper level anticyclonic outflow because it's no longer under the subtropical jet. It moves inland, weakens, subtropical jet impinges on it, and then yeah, it kind of dissipates. So yeah, environment. At first glance, it's going to get better, and some decent intensification could occur before Queensland. There's a chance that we could get a hurricane force system again. It's just that that upper level subtropical jet moves away, and yeah, it has that nice environment of upper level weak shear that we're seeing quite little of here. But that doesn't tell the whole story, because we also need to look at the mid-levels and the low-levels, because the upper levels don't tell the whole picture. And there could be some shear around, and because the Bureau said it might weaken, so the shear might weaken only slightly, that could be kind of, let's infer that it could be a sign that the shear might not be particularly low overall on the deep layer scale, because we've still got to take a look at the other levels. Now this is where I get back to my GFS sounding, and we can let's go through quickly. Let's take a look. That because it moves under or south of the subtropical jet, we can see relative humidity values are now able to wrap around freely, which again is a good sign for intensification. But there is still some shear impinging. That those values do struggle with it, like a bit initially. This is around 36 hours from the initialization, so 30 hours or so, 36, and then yeah, the values begin to wrap again as it nears the coast. That could be a component, that could be element influence from the coastline and coastline convergence increasing along there. That could have helped the evolution of a wrapping convective burst. Or it could be the environment getting a little bit better. I'm just looking at this plot for now. I haven't looked on the details on the right side yet, which I'm going to do now. So if we begin at 12 hours, we see that shear, that subtropical jet influence is still around, but we do see that decreasing slightly. That's decreased to 35 knots, and that's a bit of a short peak. So for the most part, if we do a bit of a cut off there, that's not too bad of a shear environment generally in the most in the most important areas. We still have a max shear 46 and deep layer 46 knots, but because they're in an isolated region and it's more so of a spike really. It's not really an average, and most of our shear is okay here. If we're looking at the mid levels and the low levels, it's aligned with the motion vector somewhat. There's only about 15 knots at peak. For the most part, if we're looking at where our shear most matters, which is, or where it's most detrimental, I should say, 500 millibars, you got 700 there, it's okay. 5-10 knots, going at 15, isolated. Where the storm is going, which is a temporary west-northwest movement, it's okay. It's a generally good environment, and some intensification is certainly possible. Though we do need to also look at the subtropical air lingering around, because the shear environment is not actually completely perfect. We could still see some dry air intruding into the core, and that could disrupt the system to some extent. But then, because we do see overall weakening in the overall profile, still, obviously we do have that not being so great. But then again, that is in the upper levels. What's most favourable, I guess, is the fact that it's not, the storm motion vector is not particularly too particularly strong. It's moving very erratically. We've got a big convective mass probably, where that relative humidity is in decent values in a bit of a bulk state. And in regards to shear, very weak shear, mid-level, low-level. aligns with the motion vectors. That's okay. That's okay. Fairly good. But then we also got to keep an eye on the fact that we do have shear still extending at this level, and dry air is lingering. It is trying to find a window to get in. We can see it. The lower relative humidity values are trying to sneak in a way. But the shear, for the most part, is okay, decent. For any convective development and any moisture that's around, that should generally be fairly conducive for some slight to gradual intensification. The GFS doesn't really show that, but it's certainly possible. We can even see here that with that evolving convective structure, relative humidity structure that's like wrapping around now and everything, that's probably an indication that there is some intensification going to be going on in real time as it makes landfall there. The GFS shows a 987 millibar pressure. That's around low end category 2, a normal kind of pressure when it comes to Australian scale, and that's probably a high end tropical storm. Looking at the American scale, Saffir-Simpson hurricane wind scale, to compare the two. And what does the European model suggest in terms of looking at the sounding profile? Well, again, first of all, with regards to intensity, 987, very similar evolution. You can see here, wrapping happening occasionally, and that environment is for the most part fairly equal. And if we're taking into account these values that we have here, these values do weaken because the deep layer shear does weaken. It's no longer under the subtropical chair, but we do have some upper level flow remaining, and yeah, max shear, deep layer shear, 25-30 knots for the most part. For the most of the time, it does remain. That doesn't stop intensification completely. I don't expect it to, but it might slow intensification to some extent. Now, one final thing with regards to looking at the environment and the intensity is I want to look at the HAFS-A regional hurricane model and see what evolution it indicates. We're going to look at this first, take a look at the pressure evolution, the wind field structure evolution. First of all, it's interesting to see how maximum winds are amplified under the convection wrapping around. We can see there, following the kind of red circled area. Yeah, it's generally following and wrapping around the convection. I note that because obviously, yes, that's natural, and yes, that does happen. That's not normal. Sorry, I should say that is normal. It's not abnormal. But it's something interesting to note because it's such a broad system. It's so clear. It's such a clear evolution. Very evidently seen. So that's something to note. It's quite a nice spiraling pattern that you can see as it evolves. So that's an interesting thing to look at. But let's get right into the environment. Let's begin taking a sounding, for example, at hour 36. So this is hour 42 on the model run, but because we're going to be basing off at 6E, it'll be hour 36. So just use it as a reference point for now. And we got 26 knots deep layer shear, 26 knots max shear, which is deep layer, as analysed on this model sounding. And yeah, we see that most of the shear gear is generally upper levels, and that's extending westerly. The storm is moving like literally 3 knots southwards, a very erratic movement, so let's just assume that it's moving basically nowhere. And this shear profile for the low level, mid level winds, 850, 500, very weak. It's fairly good, and that then subsequently allows for some intensification to occur. I was taking it taking this at face value, and then if we look at the convective evolution here, which I can't do because it's not here yet, but because the favourable environment is here, there is a favourable environment. We can see the vortex does attempt to tighten up. We see vortex at the moment, if we look at hour 24 or 30, very broad wind field, that tightens up, and our main vorticity is concentrated generally around there now. So it's we see that very broad wind field. Our central vorticity is somewhat like there, and then that does tighten up. Obviously, my colour could probably do a bit of work because I've chosen the wrong colour for this. But yeah, let's look at this again. We've got current. Let's look at the current wind field for comparison. Main bulk of vorticity there. That tightens up to there. I might be a bit lenient there, and I might be there. It tightens up. There is quite a bit of tightening going on. Probably around 1 degree, 0.5 degrees on each side. That's 30 nautical miles. Fairly good tightening as it occurs. That that does show that there is an environment that is supportive of the system strengthening to some extent. And as the system tightens, as the system strengthens and with kind of more of a barotropic process, and it's broad to begin with, it will naturally tighten itself, and that's what we're probably going to see with Alfred as it approaches the coast here. And then yeah, what does the HAF suggest? Landfall 72 hours at, well, using 0Z initialization. So this is 6E initialization. If we're looking at 6E as a reference point where we begin, 66 hours really on the HAF's A model. And then compare that with GFS, for example. GFS shows it inland at that time, landfall 54 hours. So there is quite uncertainty with timing. ECMWF, landfall at, I can't see, but if we look at 18Z, because that's the late, I can't even look at it on here, that's convenient for me. Yeah, well I can't see, but we did see the ensemble. There's quite a bit of a spread, even within the EPS ensemble itself. But if we look at between the models as well, the HAFs has a bit of a later landfall happening. That's around hour 66. That was around, I think, if we look at HAFs again, and it expected landfall at hour 75, 72, and that's around Friday, midday Friday really, for the Australians over there. Midday Friday, and the GFS expects landfall at about Thursday night. So there's quite a bit of difference in timing. It's not like 2 days, 3 days, but it is still like quite like half a day or so of a difference in timing of landfall when that's gonna happen. There's quite a lot of uncertainty within that we see here. It's also something to note. We definitely do have, while we do have similar intensity evolutions-ish, kind of with how Alfred's going to evolve, and we know how it's going to evolve, and we know the general direction. The steering pattern is, it's not really consistent all the way through. There will be adjustments throughout the day, throughout the next few days until Alfred approaches the coast. There will be quite a few adjustments in how the ridging is set up and how the pattern is. We know how the pattern's going to evolve, but the timing of how orientation of the ridge and any small really adjustments in the ridging pattern that occurs to the south can influence how erratic Alfred's track is going to be and how long it takes to get to Queensland and its eventual landfall. So that is the information that I have. I've looked at the regional hurricane models with regards to evolution and its timing as well, as long as most of the global models, as we've read through the Bureau discussion and for the most part the sea surface temperature analysis here, those sea surface temperatures will also warm. So it's not only shear that ends up decreasing and makes the environment a little bit more favourable, but those sea surface temperatures will increase, and we're probably going to see temperatures go up to 27 degrees C, as the Bureau mentioned. If we look here, there might be a bit of a warm spot there. I don't know if that's isolated to the OISST output, but if we look at Coral Reef Watch, it doesn't really have that. If we're being fairly consistent, we're going to see 27 degree waters by the coast 26 approaching the coast. That's as part of like together working with the together working with the overall shear decreasing, that oceanic profile, our oceanic potential will also improve and will be around to assist in any intensification that occurs. So, thank you guys for watching. This is the information that I have for Alfred and what we currently have modelled and the environment that's likely to help Alfred in the way that I have talked about. Some strengthening is possible before Alfred makes landfall, but the timing, while certainty is increasing to some extent in when and where, timing still remains quite a big issue, and I'll keep you guys updated in due course when, obviously, as we get closer to landfall. Thank you guys for watching the video. That is me for today and me talking about Alfred and its potential impacts in Queensland. Make sure to follow the Bureau of Meteorology for more information regarding Alfred and its potential impacts. And yeah, stay updated to warnings, stay safe, and I'll keep you guys updated on Alfred as time goes on. Thanks for watching.